So we have this question which says we're given a function, right? We're given this function here, this n is equal to, right, 5. So it's equal to 5 times by t, 2 to the power of t. Okay, so we just got to complete the table here. Now this is a calculator assumed question, so literally just grab out your calculator, put it into main, put 2 and then to the power of 2, and that'll give you your next result, 20. All right, now let's change that to the power of 3. 40 to the power of 4, 80, and to the power of 5, 160. Now just let the marker know that you've used calc. Okay, there's 2 marks, probably half a mark for each one of the right answers that you have here. Okay, so now let's go down to the second bit, which says, can you complete this table now? Instead of, like, now we're just going to wrap like an ln around there. So grab this guy and put in your natural log. I'll just grab him now. ln, wrap him around, and let's do the same thing. So what happens when we have this value? Okay, and so what we want to do is just use the decimal places, because otherwise it's not going to give us nice answers. So I'm going to change it from standard to decimal, and there we go. 3, something like that. Let's change it again. Let's change it again. Let's change it again. Okay, let me just write it in now. And final one where we substitute in 5 into there. 5. Cool, that's our couple of marks there, our 2 marks. Now, let's plot the data, okay? So I've got a calculator. I don't need to draw the table anymore, but if I go into here and I type in ln and grab my keyboard out, so I'll just do it exactly how you do it. ln bracket, I now have 5 times by 2 to the power of x, and we've got it from 0 to 5, right? So it's 0 to 5 here. That just changes the plot. So let's let's zoom out a little bit. So our x-min can be that 0 to 5. We have our 1-min for 0 and our x-min to 7, and that's, there we go there. So now we've kind of got our axis ticks there, so we can plot it quite nicely. So as well, if you click in here, you can go like trace, and then as you use your left and right arrows, you can quite quickly get between places, or you can, oh, you can't really tap it there, but as you can see, you can quickly scroll through stuff. So that might make it easier, but let's plot it out on our axis over here. Okay, so we've got our axis, a little wonky, and we've got that 1, 2, 3, 4, 5. And just put some arrows on here just to show that it goes on forever. And I'll also do this. Okay, so in this particular question, plot the data in B. So we'll just grab our values here. 0.1, it's roughly 1, 2, 3, 4, 5. It's roughly like that 2. And then at 0.2, it's almost 3. And then at 0.3, it's almost 3.5. and at 4, it's 4.38. And then at 5, it's just over 5. So it should be a nice straight line. Okay, I'll just give it a couple of shots here until I get it as correct as possible. Use a ruler. Obviously, it's a little hard for me to do that at the moment, but I'd strongly recommend using that ruler. And then also just let the marker know what this line is here. Okay, so this line is ln 5 times by 2 all to the power of t. Okay, and then when we have a look at our function here, it looks like quite similar in a way, and that's all we need to do. So now the next part is, let's see here, it says, explain the advantage of plotting ln against t instead of just n. And so what we see is, like, originally when we plot the other value here, let's say if I just plot 5 times 2 to the power of x, and I plot this one, so I've got to tick it and then plot it. Oh, something weird's going to happen. Let's hit default to zoom out, and something strange. Do you see how it's like it's really hard to see what's going on? So if I can just hit zoom out, and you can see it's really hard to tell like what's happening here. So you'll find that like a lot of scientific studies use like an ln axis to straighten this out because it's easier to plot. So how do we put this in words for maths? So I guess what we can say is that it's just it gives us an exponential, and this is harder to view than a straight line. Okay, so that's really the crux of it here. So it's 2 marks, and I guess how we're going to write it out. So let's say plotting ln against t yields a straight line. Okay. Linear relationships are easier to analyze. Easier. Oh, okay. Compared to exponential. So compared to exponential relationships. Cool, that's your 2 marks. So 1 mark to say that it is a linear. The other one say that linear is easier than exponential. Okay, now that you've done that, we're on to this one where it's now solving for our log functions here. Now we do have a calculator, so we can always use that to make our life a little easier. And so let's just solve for it using the calculator. So log 5 x plus 2 is equal to 3. Okay, highlight the whole thing, advanced solve, and then that's equal to 123. Cool, so how do we do this? Because that's only going to give you 1 mark by giving the answer, right? You're going to have to go through step by step and solve it. So what we're first of all going to say, I'll just scroll down, is that log, so for log 5x plus 2 is equal to 3. Okay, we're wanting to solve for x here for part f. And what we can say is that if we got log of b of something to a, and that's equal to c, well, that's the same thing, right, as saying a is equal to b, c. I'm going to prove that to you. I'm going to take this equation and I'm going to wrap it in log base b for both sides. Now, there is this rule that says that if you have something to the power for the log, you can put it down the bottom. So now we've got this log base b, and that is equal to c log b and b here. All right, you don't believe me? Let's get a calculator out. Okay, let's say I've got something like log 2 to the power of 3 to the power of 3. That is equal to 4.5, right? Let's grab the same thing, but this time I'm going to put the 3 up front. That's equal to the same thing, isn't it? So they must be equal. The other thing is that if you've got this b and b business here, that's equal to 1. Okay, let's try that. What is log 2 to the power of 2? What is log x to the power of x? It's also 1. Okay, so that's a log law there. And that's how we get to our final equation. Okay, it's just useful to know. You can either remember it by the first method, just swapping them around, but sometimes I get a bit confused, right? So that's why I have to remember wrapping everything in logs, okay? So now that we've got that, we can rewrite this top equation in the other form. Okay, let's rewrite that top equation in the other form. And so now we have x plus 2 is equal to 5 to the power of 3. All right, now we can easily solve this, right? Now it's 5 to the power of 3 minus 2. Just say use calc. And then you can grab your answer from the previous, which says it's 123. Okay? Just wherever you can, try and use the calc as often as possible. Okay? Because you don't want to make silly mistakes from trying to simplify things yourself but making errors. Okay, let's go down to part G here. Part G. Part G is asking us to solve what is a log for x is equal to 3. Now this is 2 marks, so we can just get the, I guess, equation from the calculator, but that'll only give us 1 mark. So what's really important here is that we swap it back out using the other log law. So remember that the log b of a is equal to c. Well, that's like saying, all right, b to the power of c is equal to a. So just remember that because you wrap the log laws around, okay? And a is on its own because it's the final value there. So what you can do is just remember that a is on its own. It is alone, okay? So a is on its own, it is alone. That's how you're going to remember that it's b to the power of c there. And what we can then do is say that our value of x, so that 4 to the power of 3 is equal to x. Okay, x is equal to, just use your calculator, honestly. It would be so much easier. In fact, I'd recommend using the calculator from this point here and then wrapping the whole thing in solve. Okay, that's equal to 64. There we go. There are plenty of exam questions like this that you can find on my website. So if you want to get really good marks, click the link in the description and make your way to the website and see lots and lots of questions with fully worked solutions. They're all exam level questions. So you're not stuck using the same question over and over again in a textbook. So this will really get you to learn, really get you to understand the types of questions that you're going to face in your exams and therefore get good marks.